So let's begin. Let's have a review first. So I'm waiting for your questions now. We need to start with the review so that if there are any problems, we can have it from you. You can raise your hands to ask your question, please. So I'm waiting for your questions. I'm giving you 2-3 minutes so that you may ask if some things are not clear. Okay, fine. Rohit Kumar Singh, unmute yourself. Yes, Rohit, can you hear me? Yeah, speak up, Rohit. Can you hear me? If your headphones and the system is not good, then there's no need to attend the class. It's a waste. I don't know whether you are there also. I'm not able to hear your voice, right? Okay. Guleen Kaur, unmute yourself. Yes, Guleen. Can you hear me?
Yes, sir.
Yes. Guleen, tell me, what do you understand by that HDFS is a block structured file system? What do you understand by this statement? Yes, Mridul, unmute yourself. Mridul, unmute yourself.
Yes, sir.
Mridul, what is this block structured file system of HDFS? What do you understand by that?
Uh, sir, it means that we can store the files in the form of blocks in the Hadoop cluster.
What is the default block size, Mridul?
That's 64-bit.
64?
Sir.
Yes, Niladri, unmute yourself.
Yes, sir.
What is the default block size in HDFS, Niladri?
So 64 bits. No, sir, 128 bits, sir, 128 bits.
So now we are dealing with huge files in bits. That's amazing. That's really amazing, huh? Mridul and Niladri, आप exabytes की files जो हैं, you'll be dealing with them in bits, huh? Surprising. Yes, Paras, unmute yourself. Paras Kumawat. Yes, Paras, go ahead. Unmute yourself.
Yes, sir.
Paras, we just heard that the default block size is 64 bits or 128 bits. Is that correct?
It is 64 bit. Sorry, 120.
120. What?
120 MB. Yes, sir.
120 MB.
Yes, sir.
So how will we study if you are not aware of basic things? Yeah, Ritika, go ahead. Kindly tell this class.
Sir, it's 128 MB.
128 MB. Some people are trying to deal with a cluster in bits. What should we do about them? They'll get old by the time the data processes.
Yes, sir.
So the default block size is 64 MB or 128 MB. We'll go with 128 MB, right?
Yes, sir.
Yes, Rajat, unmute yourself.
Sir,
Yeah. Rajat, how is the file stored in HDFS?
सर सर नहीं पता
कैसे पढ़ेंगे आज फिर हम?
सर मैंने लास्ट वाली क्लास नहीं अटेंड की
क्यों? क्या हो गया?
सर कहीं गया था
Very good. Very good. Yes, Prince. How is a file stored in HDFS?
Sir, actually file is stored in blocks in which there is two nodes, data nodes and name nodes. And in data nodes, these blocks are stored, and while name node execute the file system.
How are they stored? What is the policy?
So in the form of metadata.
If I have a comparison of 5CSC1 and 5CSC2, I think 5CSC2 is not picking up big data properly as of now. They're not even sure about the block sizes, leave aside how the file is stored in the block. The files that I've sent you, I don't think you have read them. So not very good. This is a thing which can be helpful to you in future. This big data analytics, machine learning, all these topics, they are interconnected. So if you're not aware, once we start doing it practically and you don't have the cluster with you, or you don't have the know-how that how we are going to work with these files, it would be a waste. Whether you fail or pass, that is up to you, that you know that you're going to pass with some 6 or 7 or 8 CGPA. That's not our concern actually. Learning should be our concern, especially when you are sitting at home and learning, trying to learn, which is a difficult task. But you're not trying well, all of you. That's what I'm trying to say. You people are not trying. You're not ready for the class. Even if I am preparing so much so that I can deliver maximum to you, you people are not up to it right now. So I don't think that was a good review. You people are not even aware of certain things. So let's see. Let's have a review from my side now. I don't know whether it's meaningful or not, because if you don't show interest, you won't learn this. And this is something which you can work with in future at your workplace, remember. So let's discuss about the HDFS daemons. HDFS is the Hadoop distributed file system. Even Prince, your answer was not very encouraging. Okay, so listen carefully now, Prince and the rest, all of you. There are three daemons in your distributed file system, namely the name node, the data node, and the secondary name node. Name node is responsible for storing metadata. It stores information about the cluster, that which block of which file is stored on which node, on which rack, and so on. Okay, and data node is the one which stores the actual data. And in a cluster, name node is the master and data node is the slave. So, or slave or worker. So it's a master slave relationship or a master worker relationship between name node and data node. And secondary name node is like assistant to the name node. It does some housekeeping job for name node. Okay. So files, when you want to store a file in the cluster, it is first split up into blocks. Okay. The blocks are managed by name node and stored by data node, and they are replicated across machines at load time. So same block is stored on multiple machines. So the availability is good. By default, the replication factor is 3, right? Then imagine this scenario that you got a file with, which is split up into 2 blocks. And if the replication is like this, then it is stored on 3 machines or 3 data nodes, 2 in the same rack, 1 in the different rack. Okay. This is known as rack awareness, that the blocks are rack aware. They know where they should be stored as per the name node topology. Name node keeps a track that which block would be stored in which data node and which rack, so that the availability is there and the fault tolerance is also there. So this is the policy. In one rack, 2 blocks on different data nodes, and the third replica on another rack on another data node. So if your file hamlet.txt is split up into 2 blocks, B1 and B2, then B1 has 3 replicas and B2 has 3 replicas, right? 128 MB is the block size. Okay. Initially, when it started Hadoop, then it was 64 MB, but now the default block size is 128 MB. And the huge blocks are there to reduce the time of seek, that is to read the files at a streaming pace. Okay, that is why the block sizes are very big in HDFS as compared to the file systems that you've been working with so far. You've been working with Windows file systems, NTFS, FAT, and in Linux we have the file systems ext3 and ext4 and XFS. So there the block size is just 4 KB to 8 KB, whereas HDFS block size is huge, 128 MB. This is simply to read the files at a streaming pace. Okay, then this is the policy of placing the replicas. Okay, it is determined by name node. Okay, and replica placements are rack aware. All the replicas don't go to one rack. 2 replicas in one rack on 2 different data nodes, and 1 replica in a separate rack. Okay, then this is the HDFS file write. HDFS file write, how the file is written into the cluster. Okay, how the file is written into the cluster. So whenever a client wishes to write a file into a cluster, it first consults name node. Then name node will determine which data nodes the blocks would be stored on. Okay, and then you can see the steps. Steps second, third, and fourth would mean that the block is being streamed to the nodes, the data nodes. Okay, and then they sent an acknowledgement back that yes, data has been stored. There is something known as a checksum involved in this. Checksum is, it would ensure that whatever file has been sent to be stored in the cluster, exactly the same file is stored. There is no corruption in the file. Okay, so we'll discuss this checksum in today's lecture at a later stage. So this is the HDFS file write. Okay, similar is the HDFS file read. When a client wishes to read a file in the cluster, then it consults name node and picks up the blocks where the block locations are, and then reads the block. Okay, so this is a concise and short description. I've sent you a file in which there is a detailed description of these read and write uh, operations. But since this is not transparent to you, you cannot see it. So you can just read it and you can understand from this diagram. Okay, this is how it is done. And name node is the major component in this. If name node is there, everything is possible in the cluster. If name node is not there, then the cluster is inaccessible. You cannot reach out to your files. That is why name node is also termed as a single point of failure. That is, if a name node is down or is not working, your cluster is not accessible. You cannot access your cluster. Okay, so then we can see, yeah, name node is a single point of failure. And there are separate, there are different ways in which we can take care of this. One is like we can have a federation, HDFS federation sort of thing. And one is a high availability name node. So we'll discuss these two things. I'll just load one file in front of you and we'll discuss these two things, right? The file is not there. Just a second. Let's see if we can get it from your portal. Just a second, I'll just get a file for you so that we can discuss a few things about HDFS and then we'll shift to the cluster. Practical work today. So let's see. I've started the cluster, that's why the speed is a bit slow. So we are doing this in today's this thing. Yeah, this should be the file. Yeah, let's take it from here. So if you can see the screen and if you can see the file, you can just give me a quick and all of you. Because for the next 10 minutes, I'll be discussing a lot of things with you. Just raise your hands that you can see the file HDFS. That's there in your dashboard also. You can refer to it later on. So quick recap of your entire HDFS before we switch to cluster today, right? We'll see how actually it looks like. Okay, so HDFS, it's a storage component of Hadoop. It's a distributed file system. These are the features. Okay, scale out, high availability, replication, fault tolerant. So all these features, they are there with HDFS. Replication, we have just seen that your file, your blocks are replicated. The default replication is 3. And if there are some critical files, the replication can be high also. Or it can be low also. You can set it in your configuration file. Then it is fault tolerant, that if one of the data nodes is not working, then you can get your data from some other data node. And it is good for easy storage of large data set. And you don't require any special hardware. You can just work on with commodity hardware, right? Then it is based on the GFS, the Google File System paper written by Google in 2003, is written in Java, and it runs on top of the basic native file systems like ext4 and ext3. That means that you have installed Hadoop on your Ubuntu system. Your Ubuntu file system is ext3 or ext4, okay? And that means that your Hadoop runs on top of this, and it works better with large files, and it's write once and read many concept. That means it is not meant for updation of files, it is meant only for reading the files at streaming pace. Okay, there is something known as a self replication also, which means that if one of the data nodes is not working, then whatever blocks were present on that data node, they are not available. So name node then sees that their copies of those blocks are lying on some other data nodes. So it copies it from there, looks for a new data node and copies the blocks there, so that the replication factor is again set to 3. Okay, this is the process of self replication, and this is done by the name node whenever it starts up. Okay. So this is the design assumption, this we have already discussed. This is the architecture. Okay, so you can see the name node and the data node and how the files are stored. Then the architecture is a master slave architecture, in which name node is the master and data nodes are slaves. Is a block structured file system. The HDFS namespace is there for the user to interact. So your name node has a namespace where that means all your metadata is in the RAM. So your name node or your admin machine requires a large RAM, big huge RAM, right? Not a just 8 or 16 GB. Minimum 64 GB or 128 GB RAM is required by the name node, because it has to store the entire metadata in it, right? Then these are the details of name node. This you have already discussed. Okay, so one thing is there, it was a single point of failure. Now HA is present. You can see that bullet, right? HA is high availability. I'll discuss high availability with you soon, right? So name node is not, if it is not working, your cluster is not accessible. Yeah, important point now, and listen carefully. If you wish to write, you can write on your copies also. Uh, this name node, it keep records on disk for recovery from any kind of crash, and basically it stores two files. There are two files, edit logs and fs image. Okay, edit logs you can say, otherwise the file goes with the name as edits. Okay, edits and fsimage are the two files which are there in the name node. Okay, what are these? We'll see. This is secondary name node now. It is not a backup of name node, it's a separate process. It helps name node to do certain housekeeping jobs. Okay, what are those housekeeping jobs? Is that it merges edit logs with fs image. Okay, this is the idea behind secondary name node process. It merges your edit logs with your fs image file. Okay, so let's now discuss this, that what actually is this edits and fs image file. Okay, yes Shaman, please ask. Shaman, you raise your hand. Yes, Vasu Malik.
यस सर, गुड मॉर्निंग सर।
Good morning.
सर मैंने पूछना था नेम नोड में सर वो एडिट लॉग एफएस इमेज और एक सर एडिट लॉग न्यू एडिट लॉग भी तो होता है।
हाँ जी,
आई थिंक सो। एक सर
yes.
न्यू एडिट लॉग भी होता है ना, जब वो प्रोसेस होता है चेक पॉइंटिंग का, तो जब वो उधर ऐड कर रहे होते हैं तो वो ये टेम्पररी होता है एक तरह
Yeah,
का एडिट।
I'm coming to that. I'm going to explain that thing
ओके
in detail, right? Just wait.
ओके,
I'm going to
थैंक यू सर।
explain that in detail. So we'll discuss about this. What now? You see, when your name node has two files. Okay, one is a permanent, a persistent file, fs image. It's a permanent file, and one is a changing file, which is known as edits. Okay, actually, edits is a series of files. It's not one single file. It's series of files. Okay, so if you see fs image, you know, fs image contains the entire cluster. Okay, and what we wish is that once your cluster starts, then name node, should not be recording all the changes that are taking place in the cluster simultaneously, because then name node's performance uh, reduces. So what we do is that whatever changes are taking place in the cluster, whether files are being added, files are being removed, okay, files are being copied from one place to another, all these changes are recorded in your edits file. Okay, and once a period of time elapses, then these two files are merged. Okay, when these two files are merged, this merging is done by the secondary name node, so that name node is free to for the clients and the users to work with freely. Okay, so secondary name node takes care that these two files are merged, and we get a new fs image file, and the edits file is blank. Okay, now this could be either after a fixed interval of time, number one, or it could be when your edits file reaches a specific size. So these two properties you can mention in your core site.xml file, that is your configuration file. So these properties are fs.checkpoint.period, okay, and fs.checkpoint.size. So if you set fs.checkpoint.period equal to 3600, okay, this period value is in seconds. That is the default value. So that means if you set this fs.checkpoint.period equal to 3600, that means your name, your fs image and your edits will be merged after 1 hour. So if you are having a critical cluster, like where you think that this time should be less, you can set it less. But by default it is 1 hour, 3600 seconds. But it is configurable. You can set it as you wish with this property fs.checkpoint.period. Similarly, if you think that 1 hour is too big a time, and by that time your cluster is very busy, is a lot of users are working there, and the size of the edits file will increase so much that it may consume all the RAM. So in that case, you can set this fs.checkpoint.size property. Okay, so you can set this size in bytes, and once you reach that size of the edit files, this checkpoint it occurs. Okay, that is a merging of FS image and edits file. Yeah, your questions now. Your questions on this? Simple process, I repeat. Permanent file FS image which contains all your cluster. Edits file which records the changes which occur when you are working in the cluster. Both these files are merged by secondary name node through whenever a checkpoint occurs. The checkpoint interval by default is 3600 seconds or 1 hour. And if you wish that you should not wait for 1 hour, but you wait that your edits file reaches a specific size and then you should merge them, then you can use that property, right? The size property. Any questions regarding this? Regarding this FS image and edits? Yes, Ritika, go ahead.
So edit logs file is for particular session or it continues till it
It
merges?
continues. It continues. Whenever you start your cluster, okay, then we begin with a blank edits file.
Okay.
Okay, because all
Yes.
the changes, all the contents of edits are merged with FS image. Then we don't need the edits file anymore. I'll show you all these files in the cluster today. Don't worry, you will understand. I'll show you
Okay.
each and everything in the cluster today, right?
Yes, sir.
Yes, Mridul, go ahead. Ask your question.
Sir, in Hadoop, edit logs holds all the information about the metadata. Then what's the
No,
need
no,
of
no,
that?
no, 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 no. Edit logs, no. All your metadata is in the FS image file. Okay. So that metadata is changing whenever you are using cluster, you are adding files, you are moving files, so metadata changes. So all these changes are recorded by the edits file. And after a fixed interval of time, which is by default 1 hour, both these files are merged and your FS image is updated and edits is blank. This is done so that your name node is not burdened.
Okay.
All right, we'll
Yes.
see this. Don't worry. Yes, Pani, go ahead.
Sir, after merging these two files, will it be stored in hard disk or will it be on RAM?
No, it's there. All these operations are in RAM, but this FS image is a persistent file. It contains all that. All the metadata is there in the FS image file, which is a persistent file, permanent file. It's not in RAM. It's in secondary storage. It's in your name node hard disk that you have, the server hard disk, right? Okay. Okay, so let's have a quick poll. Remember the time is less, just 30 to 35 seconds. The poll is in front of you. Read carefully and then answer. Don't rush with your answers immediately, but time is limited. The poll is in front of you now. 20 seconds left now. Even if you don't answer, I'll close this poll. Don't worry. 15 seconds. I repeat, read the questions carefully, please. You attended a half an hour session, read the questions carefully. Okay, last 10 seconds now, whether you answer or not, that's not my concern. I'll count to 5 now. 1, 2, 3, 4, and 5. I'm going to end this poll now. I'm sharing the results with you. Only 6 people have answered the first question correctly. You didn't read it properly. 27 or 56% are answering that data node is a master node. Just see, you're not reading. The question is data node and name node are respectively which of the following? So data node, are both of them worker nodes? No. Data node is a master node? No. Are both of them data processing nodes? No. It is none of the above. The answer is none of the above, right? Data node is storage, name node is metadata. So none of the options was there. Second question, well, it's the only 33% people have answered it correctly. The answer is block ID and host name of all the data nodes containing that block. Okay, name node कैसे respond करता है? It gives you the block ID and the name node address, the IP address of the name node. That's it. Okay, how come 18 people have answered size of the file requested? What has the size to do with it? Okay, so first question, none of the above. Second question, the first option. You're not careful. That's what I'm telling you. That's what I told you at the beginning of the lecture. 2 घंटे क्लास पढ़ना एम नहीं है हमारा. 2 घंटे में मैक्सिमम गेन करना है so that we can understand what is big data analytics. I'm relaunching the poll. Answer correctly now, all of you. Answer correctly in 10 seconds. I've relaunched the poll. Answer in 10 seconds. Now you have 5 seconds. Yeah, I'll count to 5 now. 1, 2. Still, some people are, adding both are worker nodes. See, that is a problem. And believe me, I'm going to keep a good track of all these people who are answering, just like that. I may ensure that they even don't pass this subject. And you know me very well. If you are not attentive, some of you are answering even after me telling you the correct answer that both are worker nodes. 3 persons have answered. So these 3 names would be with me. And some are also answering size of the file requested. So don't worry, I'm keeping a track. I'm going to ask all of you, why you're answering like this and why I should pass you in this subject. Okay. So your names have been recorded now. Okay. मैंने share किया आपके साथ. So these 3 people who have answered first question as first option, they should be careful. They are on my track now, my radar. Similarly, the second question, 4 people have answered size of the file requested. So obviously I'll keep track of these people also. I'm going to keep a track of all of you, don't worry, right? Okay. Let's move further. Then the HDFS concepts are there. The data node, it stores the actual data. It is not so critical, even if it is out of order, it's fine. Then one important thing about your data node is that it does 2 things. It sends a heartbeat to name node to indicate that it is alive. It is sending heartbeats, right? And it sends block reports to name node to tell that it is alive. Okay, 2 things it does, heartbeats and block reports. So this heartbeat is sent every 3 seconds. Okay, by default the heartbeat interval is 3 seconds. After every 3 seconds, every data node sends a signal to name node that it is alive and working. And similarly, after every 6 minutes, okay, after every 6 minutes, it sends a block report to name node about all the blocks that it has, okay, in it. So if any of these things is missing, that name node will assume that your data node is not working properly, and it will copy all the blocks from the data node to a new data node. Remember this thing, if the heartbeat or block reports are not received. Okay. The next is your this was regarding the blocks. We had a good discussion about it. Default you keep in your mind as 128 MB, remember, not 64 MB. Default is 128 MB, right? How files are stored, this we saw. I'm repeating this thing because this thing will come in front of you in the next half an hour in shape of your cluster and you will actually see all these things happening there. Okay, I don't know how many of you have installed the cluster. So I have sent you the maximum help that I can, and being in third year of computer science, if you cannot install a cluster with so much help, then I can't help it. Okay. So what is the block size of typical file systems like ext4 and TFS? Yes, your answers. The file should be there with you. You can give the answer. No, nobody wants to answer. So it is a few kilobytes. The file system that you are using, the Windows or the Linux, the block size is less, 4 KB or 8 KB. And why HDFS block size is much bigger as compared to typical file system? It's that we want the reading of files at a streaming pace. So we may take some time for the file to be stored in the cluster, but once it is stored, it should be read at a streaming pace, right? Then HDFS is not for your small files or file updates. It is simply there to read huge files at a streaming pace. Then this the write operation we just discussed. Okay, so there's a lot of detail here. You can refer to it, how it is done. The detailed description is there. You can read it and you can discuss with me. It's not very important, you know, because this is something which happens in the background, but you should see that what all processes are involved in it. I discussed it briefly with you. Now you can have a detailed reading from this file. Similar is with your read operation. Next is how to interact with HDFS. Either you can use a command line interface, that is HDFS commands, or you can use some Java programming, Java application programming interface, right? Then HDFS limitations, you know, the single name node and the name node is a point of failure, single point of failure. So the remedial measures for this SPOF, we have said name node is a single point of failure, and we could have a HDFS federation sort of thing, in which you can partition your you know, file system data into multiple name nodes. That some portion of your files in name node 1, some in name node 2, and so on. So this federation sort of thing is difficult to manage, so we don't recommend this. What we recommend is something like this: HDFS high availability. Okay, in which in your cluster there are two name nodes, a secondary name node, active name node and a passive or a standby name node. Okay, so high availability means that your cluster is having two name nodes, active and passive, or active and standby. So if any of the name nodes goes down, the other can take its place. And the data nodes, all the data nodes in your cluster are sending block reports to both the name nodes. So I discussed with you that data nodes, they send heartbeats to name node to indicate that they are alive. The heartbeat period interval is 3 seconds. After every 3 seconds, a signal is given. Heartbeat is a signal which is given by a data node to name node to indicate that it's working. And similarly, there is a block report of all the blocks that a data node contains. It is sent every 6 minutes. Okay, and both these values are configurable in your HDFS site file, HDFS site.xml file, right? So this is the end of this. So if you have any questions, you can ask before I actually shift to your cluster. Let's see if you have any questions. Yes, Bunny, go ahead.
Sir, in the last slide, the line was given that data node sends a block report to both
Name nodes.
name nodes.
Yeah, that's it.
Sir,
You see, data node is sending a block report to name node. So
yes.
when there are two name nodes, then data node sends a block report or a heartbeat also to both the name nodes, not just to active.
Sir,
Okay, active name node is active, and standby name node, they are the same data. Whatever data metadata is there on active is there on standby also.
Okay, sir.
Fine.
Okay, thank you, sir.
Okay, raise your hands who have installed Hadoop. I'll count. I'll count. Many of you have done it. That's good. And it's working, right? If it is working, then it would be very interesting class for you from this point onwards. I can assure you that. Plus a lot of things which you are not seen on your cluster maybe, you'll see it. So be very attentive now. No theory now. Whatever you have read, you will see each and everything happening in the cluster. Okay. So let me go to my virtual box. Yeah, it's already there. And this is my Ubuntu 16.04. Okay. So you could use 18.04, 20.04 is your wish. What is the Hadoop version that you have installed is also important. Okay. Now listen carefully. If it is a Hadoop 2.x, that means 2.8, 2.9, and if it is a 3.x, then some commands are different. Okay. I'll be mentioning them whenever some situation like that comes. Okay. So let's start the cluster. So once we are in our this thing, once Hadoop is installed, we just start Ubuntu and we go to terminal. Okay, that is the first step. We go to terminal and we will start the distributed file system services. Note these points very carefully, all of you. Those who have installed Hadoop or even those who have not installed Hadoop, they will install and they will check all this. So once done, you can issue this command. This is to start the distributed file system services. So it will first start name nodes, then data nodes, and then secondary name node. So the command to start your distributed file system services is in front of you, start-dfs.sh, right? This is the first thing you need to start your cluster. Please do write whatever I am telling you, you might forget it later on, right? Then to see whether all the processes have started, use the JPS command, Java process status. You'll see that all your services have started, processes have started. That means you are ready to work with your cluster. Okay. Now, in my previous class, I did discuss a few things with you. If you wish that I should discuss them first and then I move ahead here, you just give me a raised hand, that will be an indication. Do you want me to discuss ls command with you, or I assume that you know it? Okay, I've got your point. So I'm going to discuss the ls command in a fast track way. Kindly note some of things you might be knowing, some of the things you might not be knowing. Issuing ls will list all the files, right? So the file, color scheme, by default is that your text files are in white, the folders in blue, and your executables in red. That is this thing. Now, if I want to list the files vertically, what should I do? Raise your hands, please. It has listed the files horizontally. If I want to list the files vertically, okay. Yes, Bunny, go ahead.
Sir, ls space hyphen l.
No, vertically I've said.
What vertically?
Just the files, not the details. You were saying this, right?
Yes, sir.
This fine. This lists all the details also.
Yes, sir.
I'm asking this note ls hyphen minus 1. Okay? Similar to your ls but vertical. ls space hyphen 1. This is to list your files, just the file names and the directory names vertically. Okay? Then to what will this command do? Please answer if somebody can. Raise your hands. What is ls hyphen a? Hyphen a or hyphen capital A, both will work. It will list your hidden files. Okay, hidden files are the files which begin with a dot or two dots, single dot or double dot. Okay, these are your hidden files. Usually not shown to user directly. Okay, ls hyphen a to display the hidden files. what is this? See the output on top. You can see it's in bytes, the file sizes. This is a human readable form. Long listing in a human readable form. Okay. Is that fine? This is about ls. Then you should also remember a few things that I told you, that whenever you are a user in Ubuntu, your access is from your home folder. Remember, home folder and down. So your home folder you can see by pwd. This is the name of your home folder, this hd user. Okay. Then we can also use this command to see the username. Okay. Uname will tell you about your system. Okay. Username would be with this, I suppose. Yeah. To list your system name and your system details, you can use uname. And to list the username, who am I? To list all the users who are currently logged in, use w. Okay. So only if you are like in working in a multi-user environment, so you can see a long list of users. So hd user is there. Okay. So I log in at 9:23. Okay. Fine. And I've been idle for 1 hour and 33 minutes. We just started working in the last minute. Okay. So these are the things, these commands I'll work, all the Linux commands I'll discuss with you. There are many, for example, let's see the list of files. There's this file 5csc1. Let me just display its contents. I'm doing this because it would be easier for you to work with the HDFS commands after this. So say this is, if I want to append something to this file, I can do this. See carefully now what I'm going to do. So if I list it again, now it has appended. So there are two commands, head and tail. So what does the head command do? Can anyone tell me? You can raise your hands to answer this. What does the head command do? Nobody is answering. किसी को नहीं पता हेड कमांड क्या करता है? लाइनेक्स नहीं पढ़ी आपने पिछले सेम में? Anish Podal wants to answer. Okay, go ahead, Anish.
Sir, it will list first 10 lines of the
Yeah, so head command is used to list first 10 lines, or you can mention the lines on your own also. If I just want to see the, the first 2 lines, okay. So there are many ways I can just write like this. Okay, so you can see the first 2 lines. This can be mentioned like this also. Okay. So the choice is yours how you write it. Okay. And if you just write without any arguments, then it will display the first 10 lines, in this case all the contents. Same is with the tail, but it starts from the bottom. Okay, so tail -1 5 csc1, what it will display? Can somebody tell me? Okay, Parth wants to tell. Go ahead, Parth.
Sir, E.
Okay, good. So head and tail commands are there. Okay. So commands like this I'll discuss with you in detail in one, maybe a half an hour, 40-minute session of a 2 hours class. We'll discuss all the Linux commands so that you know most of the Linux commands. Okay. So let's now get back to our HDFS. Our cluster is ready for us to work with. Okay. So if you wish, now very important, you may have to write this, all of you, right? You can write whatever I'm telling this thing. You can note it as per your requirement, that whenever we are working with Hadoop commands, the start is this Hadoop FS. All the Hadoop commands start with Hadoop FS, where FS stands for file system. Okay, so whenever you need to work with the Hadoop command, it begins with Hadoop space FS. Where this FS stands for your file system. And then Hadoop commands are similar to your Ubuntu commands, but with the difference that they begin with a hyphen. So if I want to list all the files in my cluster, I'll simply write like this. Let me first try this. Okay. Now I hope that you are noting whatever I'm telling you. It would be very good for you. You would be working easily on your own clusters, right? Let's have a quick answer from somebody what this will display. If I just write this, just like this, what will this display? Somebody can answer? No? Okay. Okay. Money wants to answer. Let's have an answer from Money. Yes, Money, go ahead.
Sir, just the files uh, stored in the cluster.
Stored in the cluster. That's a very vague answer, Money. Stored in the cluster, but where?
Where?
Have I mentioned any path?
No, sir.
That would mean what it would mean? Just have a look here again now. What does this do? If I just write ls, what does it lists? It lists, okay, Ritika wants to answer. Yes, Ritika, go ahead.
So it will list all the files in the home folder.
In the home folder or wherever we are currently. Wherever we are currently.
Yes.
Presently, wherever we are. So it will list the files which are present in the home folder or wherever we are present right now. Similarly, with this command, the similar is with this command. I'm taking a lot of time with this because it is important. If I just list this command, first see if it lists something. Let's first check it. See, it says, and note it carefully, it says there is no such file or directory. That means from wherever I'm trying to list the files, that path is not responding. Okay, let me now just modify this, add this. Now I'm saying list all the files in the root directory of the cluster. Okay, root directory of HDFS. Let's see what it responds with. Look carefully at the output. So it says that there are 4 files, found 4 items, 3 files and 1 directory. Okay, we have not discussed this. I'm assuming that you know whatever is there in front of your screen. The output from left to right, hyphen RW hyphen R hyphen hyphen R hyphen hyphen 1 HD user supergroup 33. You know, this is similar to your LS listing. So even if you don't understand it right now, I'll discuss it in the next class. I won't be wasting time on the output of the LS command today. Okay, I need to tell you so many things in your cluster. So these 4 files are found in the root directory of the cluster. Can you see? There is one file 5csc1, okay, and there is a directory Amit, there is a executable tar file, and there is a file puja, right? I want to display the contents of this file 5csc1 which is stored in the cluster. Can somebody help me? Remember, the commands are similar to Ubuntu. I repeat my question. I want to display the contents of this file 5csc1 which is there in my cluster, not in my local file system. 2 things, write 2 things on your copy. There is something known as a local file system. There is something known as a distributed file system. Okay, local file system is when we started Ubuntu, when we didn't start the cluster, whatever was we were doing, that was a local file system. Now the commands that you're writing now, you're working with your cluster. It is listing files in your cluster, not in your local file system. See the difference? Hadoop fs-ls / lists all the files in the root directory of your cluster, whereas simply ls lists your files in the local file system. So I want to display the contents of the file 5csc1 in my cluster. Can somebody help me? It's not difficult. Ritika, you've already answered. Somebody else? Ritika, lower your hand, please. There are so many other students. Why don't they try? Mridul, you've already answered. I'll ask myself. I've unmuted. Somebody please answer. Yes, Shudeval.
Yes, sir.
Yeah, answer.
So Hadoop FS.
Yeah. Why didn't you raise your hand? Aapko aata hai to? Yes, go ahead.
Cat.
No. Hyphen cat.
Hyphen cat.
Yeah.
Then the paths slash
Path
5
is
CS.
slash, yeah, 5 CSC1. So it is listing from the cluster, you see. This was the original file which I created with 5 CSC1. So I had stored it in the cluster. Okay. अभी आपको ये नहीं पता भी cluster में store कैसे करना है. Good answer, Yash. Well done. Okay. Now, अब आप क्या चाहते हो? आपको cluster दिखाऊं या भी कुछ और commands ऐसे चलूं? First, make yourself comfortable on the command line. Okay. So let's now put this latest file 5csc1 on the cluster. Note carefully, please keep on noting whatever I'm doing. There is a put command which is there to transfer files from your local file system into the distributed file system. I repeat, to transfer files from your local file system into your distributed file systems, you use the put command. Okay, put and then the name of the file, that's it, and then the path where you want to store it here. अभी path की बात देखें आहिस्ता आहिस्ता कैसे इसको हम पूरा elaborate करेंगे. You'll be surprised. Who wants to answer this? What will happen when I run this command? Try, somebody. I may extend today's class till 12:15 also. Okay, so be prepared with your glass of water and all. Ritika, no, wait. Oh, what's the problem? I've told you, all of you, hyphen put is used to transfer your file from the local file system into the distributed file system. That means I'm trying to copy the file 5csc1 into the root directory of the cluster. So that file is already there. So it will tell you file already exists. What's the problem in answering this? Right? There is already a file 5csc1, so it is not overwriting. Now let's suppose you want to overwrite it. Okay, so let's do it. Just add this hyphen f for force. Put के साथ अगर hyphen f लगा देते हैं, that means it will force, it will overwrite the existing file. Now it will do. Now see the time on your screens. The time of the file 5csc1, it was 25th August 11:32. Can you see on your screen? I'm just highlighting it, right? So if I again use this command, that time would change. It would be today's date and 11:07, I suppose. 11:08, yeah. Got it? It was 33 bytes, now it is 43 bytes because we appended something to it. And if I display the contents, it will display the contents now, A, B, C, D plus that line that we wrote. It is now displaying from the cluster. Okay. Is that clear? Okay. Now important thing, you may write if you wish. Just like you have a home folder in your local file system, similarly there is a home folder for user in the distributed file system also. Okay, the name of that home folder is /user. I'm writing on screen /user/username. There should be one folder with this name in your cluster. I'm saying this, okay? Just like in Ubuntu, in Linux, you have a home folder for user, which is /home/HDuser, isn't it? Let's see it. This is the home folder in the local file system. What I'm suggesting is there should be a similar folder in your HDFS. Okay, like many of you told me that you have installed the cluster. Did you see the web UI of the cluster? Just raise your hands. We are seeing the command line interface of the cluster through the commands. Okay, Parth has seen, so let's ask Parth. Yes, Parth, go ahead. Have you seen the web UI?
Yes, localhost 9870.
Okay, so if we want to go to the the web UI of the cluster, we need to go to port 9870. Okay, but this is for version 3.x, that is version 3 and onwards. For version 2, all the version 2 Hadoop versions, it would be localhost :5070. Kindly note, अगर आप में से किसी ने वर्जन 2 पॉइंट कुछ किया है, So you must see the web UI by writing this in the browser, localhost colon 50070. But if it is version 3 and onwards, it should be localhost 9870. So let's go there. Let's go to the localhost. In the next half an hour, 40 minutes, we are going to discuss lots of concepts, okay? So just note. Let's write this first. It will not work here because this is version 3.2.1. So let me just make it 9870. So it will show your cluster. Important. I hope you can see the cluster on your screens, all of you. Okay. So right now you are seeing the name node. Okay. So when all of you have configured your clusters through the configuration files, I'll come to it next. So you mentioned this as your name node address, localhost colon 54310. आप लिख रहे हो, I suppose, right? So आपको अगर अपने क्लस्टर को रेफर करना है तो you can refer with this also. How? Let's see. Keep on noting, please. Important point I am writing. I hope you've understood. Kindly note that is the address of your cluster, HDFS colon / localhost colon 54310, and after that slash is the root and 5csc1 is the file. Important thing, keep on noting. If I just write this, somebody to answer. These answers are important, please, okay? So try. If I just write this, what is the meaning? Now everybody can answer. Ritika or Mani or those who have answered before, they can answer now. If I write this, what I'm trying to do, whether it works or not, we'll see. What I'm trying to do with this, just correlate it with this command here. Yeah, I'm waiting for your answers. Okay, go ahead, Parth.
So will this list all that we have in our Hadoop cluster, all the files in our Hadoop cluster?
I'm afraid not. Yes, Ritika, go ahead.
So it will list all the files that we have in our local system, local cluster.
I don't like the usage choice of your words. Repeat again.
It will list all the files that we have in our local host user of the cluster, that is HD user.
Perfect. Yes. So let's choose the words correctly. Okay. I'll tell you what it will show. Listen, all of you. Okay. It will display all the files in your home folder in the cluster, which I just wrote. I'm trying to list all the files present in my /user/hd user folder, जो कि मैं बोलता हूँ कि होना चाहिए, right? So इसको ऐसे कर देते हैं, ये फिर बोलेगा कि नहीं है, it won't show you anything, है ना? It will say no such file or directory. You see, I'm slowly trying to bring you. Parth, you want to ask something? Otherwise, you can lower your hand, please. Yeah. So once again, final time, I'm saying there is something like this in your cluster, which is your home folder in the cluster. Okay. So when I see the web UI, this user folder should be visible. Okay. So let's go to web UI now. Okay. So this is the information of your name node. Okay. You can see I have to, so many things to discuss, but I'll discuss them slowly. Okay. You keep on noting whatever I'm discussing, then you can ask later on your questions. You see, it's all there, whatever storage is there. And you see, a live node is only one. Okay. And there are no under replicated blocks. We'll discuss this also. Okay. see the name node now, important thing for you. Okay, see edit log file, see the edits. So whenever your merger of your FS image, important point, whenever the merger of your FS image and your edits has not taken place, the merger has not taken place, then the file which is recording all the changes in the cluster is always the file with the name as edits underscore in progress, something like this. Okay, and if suppose after some time we merge and this 294 file edits file is merged with your FS image, a new file would be created with the name as edits underscore in progress underscore this 295, something like this. Okay, and you can see name node, see the storage directory. Very important, your image and edits, your FS image and edit files, it is in this location. I'll take you to this location soon. This location is given by you when you install your cluster. If you agree, you can just raise your hands because I've been speaking for quite some time now. If you agree to whatever you are seeing, you can raise your hands, please. All of you raise your hands if you agree, if you understood. You see, I discussed edits and FS image. So these files, the FS image file and all the different types of edit file, they are in this folder. I'll take you to this folder soon. Okay. Then this is the storage and all. You don't need to look too much into it, right? One thing. Then you can see all other things. You can see, we can discuss it later on, not today. Okay, what it means. Let's go to our file system now. See, click on utilities. The first option, browse the file system, will take you to the web UI of your file system. Can you see the web UI? Have a good look. Okay, and if you need to ask something, I'll give you a chance after some time. See the files which you see in front of you. Okay, and I'm listing the same here. Do they match? Have a look. See, 4 files. Names are 5CSE1, Amit, Hadoop, Puja. Same here. The same are here. Now see, there are a few things. The permissions are there, similar to your ls command. The owner is there, the group is there, the size of the file is there, the last modified is this there, replication is there. Replication, you remember that how many blocks of this, how many blocks should be replicated. So replication I have set as 1. Okay, and block size I have set as 4 MB. ये मैंने खुद सेट किया है कॉन्फ़िगरेशन में. ठीक है, अब क्या करें? Shall we see the configuration? ये कैसे किया है? Lower your hands first, all of you. Lower your hands. Now what do you want? Shall I go into the configuration files and show you how it is done? One thing, or shall we discuss about user? अगर आप कहते हो user के बारे में करें तो hand raise करो. नहीं, अगर hand raise नहीं करते हो, that means you want me to discuss configuration files with you. Good, configuration files. We'll discuss it. Okay, we'll discuss configuration files. User भी आज कर लेंगे, don't worry. So what is the meaning of all this? Let's go here. So when you, let me just open one file of interest for you. There is my folder. I'm opening one file for you. This is a file I sent you, if you remember, and these are all the configuration files. Okay, let me focus on 1 or 2 files today, maybe some more in the next. Let's take this file, HDFS site.xml, right? So it's located in this folder, we know that. These are the configurations. First, we create 2 directories, name node and data node at this path. Okay, remember this path, user local Hadoop store, this. And then we set this. Very clearly you should see dfs.replication I have set as 1. And the block size, here it is 1 MB, in my cluster I have set it as 4 MB. So let me show you the files. If you wish to write anything, you can write. If you need to ask anything, after 10 minutes. So this is my HDFS configuration file, right? You can see I've set the replication as 1, okay? And I've set the block size as 4 MB. Can you see here? I've set the block size as 4 MB. मैं क्या करता हूँ, मैं replication 2 कर देता हूँ आप लोगों के लिए, ठीक है? और ब्लॉक साइज को मैं कर देता हूँ 2 MB कर दें. For future files, I want to change the block size to 2 MB. So calculate करना पड़ेगा, है ना? What is 1 MB? Let's see. It is 1024 into 1024 into 2. So 2097152. I'll set the value here 2097152. So remember, I've changed the configuration. I've changed the replication factor to 2 and block size to 2 MB. And I'll save this file. Now, if I create a file, if I create a file now, say, let me create a file in the local system. Let's say I store this. This file is created. Let me just transfer it to my cluster. To root. You see, I'll show you the status here. अभी ये फाइल यहाँ पर नहीं है 5CSE2. मैं इसको यहाँ एंटर कर देता हूँ, ठीक है, और यहाँ आ जाता हूँ. यहाँ से कॉपी हो गई, यहाँ से होगी कॉपी, यहाँ आ गई. इसको रिफ्रेश करेंगे तो यहाँ आ जाएगी. Can you see the 5CSE2 file? Important for you to see. The replication is 2. Block size is 2 MB. मैंने चेंज किया अभी इसको HDFS पे, आपने देखा सबने, है ना? इनिशियल जब मैंने किया था तो मैंने replication 1 रखा हुआ था, block size 4. So all these properties are configurable. You can configure them and they are active as soon as you save the file. Now let's see one more thing. Tell me, all of you, the block size for 5CSE1 is 4 MB. Okay, I will be waiting for your answers and questions now. The block size is for 5CSE1 is 4 MB and its size is 43 bytes. Okay, so how many blocks for this file? Raise your hands. How many blocks for this file? If you don't understand this, that means आपको storage की समझ नहीं है. Only one person is answering. Ritika. Discuss किया तो था हमने कि अगर हमारे पास एक, if we have a 300 MB file, okay, let me just go to screen, you know, so that you can answer. Good morning, all of you. Say I have a file which is 300 MB, a file of 300 MB size. Say the file name is A1 and my cluster block size is, yeah, let's take a specific example here, similar to our cluster. Okay, there is a file of say 10 MB and as you see in my cluster the block size is 4 MB. Okay, so how many blocks for this file A1? You can raise your hands to answer now. How many blocks for this file A1? This is the file size, this is the block size. Yes, please answer.
It's MB.
Mridul, you are answering?
Yes, sir.
Mridul, I'm asking you how many blocks this file would be split up into. That is what my question is.
Sir, 2 blocks.
Okay, size of the blocks?
4 MB.
4 MB. तो ये 8 10 है, 4 और 4 तो 8 होता है. It should be 3 blocks, 4 4 2. What is the problem in this? This is the file size, when it needs to be stored in the cluster, it must be split. It must be split according to the block size. इसको split करो. One block 4 MB, another block 4 MB, third block is less 2 MB. Okay,
Yes, sir.
so that is how it is done. So I'll come back to screen. Okay, that's very important. Our next 15 minutes will depend on this knowledge. Okay, Parth, you can lower your hand, please. If there is no question, lower your hand. Yeah. So how many, now again the same question. This is the file 5CSE1. This is the size 43 bytes. This is the block size. So how many blocks for this file? Answer now. Raise your hands. Okay, new people. Yes, Varisha, go ahead.
One block, sir.
Yeah, one block, simple. अगर if the file size is more than 4 MB तो दो block बनेंगे. File size ही 43 byte है. Let's see the block. I'm clicking on this file. See, the details are there. There's only one block. See, block 0. That's it. The name of the block is block 0 and its block ID is this. इसको ध्यान से देख लो, इस पे डिस्कशन करनी है 15 मिनट अभी, ठीक है? The size is here. Okay. Now you will say कि sir ये तो समझ ही नहीं आया हमें. Okay. Look at this file now. This is a challenge for all of you. Can you see this file Hadoop -3.2.1? देख रहे हो ना? इसका size देखो 342.56 MB. Block size देखो कितना है इसके लिए 4 MB. How many blocks for this? Let's see who answers fast. Varisha, lower your hand first. How many blocks for this file? Hadoop 3.2.1.tar.gz. Sorry. Okay, Prabjot Singh is the fastest. Go ahead, Prabjot.
Sir, 86 blocks.
86 blocks. Very good, Prabjot. Okay. Let's see whether Prabjot is correct or not. I'll click here. Okay. So, see whether Prabjot is correct or not. 86 कितने होते हैं? Block 0 से block 85. See? Is correct. Can you see there are 86 blocks for this file? Okay. What is the size of block 0? Kindly have a look. 4 MB. Block 1, 4 MB. Block 2, 4 MB. Can you see the size? Okay. What is the size of the last block? Prabjot, if you are still with me. Or somebody else can raise hand to answer. What is the size of the block 85? Block 0 से block 84 तक सबका size 4 MB है. What is the size of block 85? That is the 86th block. Come on fast, we have so much to do. Yeah, Ritika. Yes, Ritika, go ahead.
Sir, 2.56 MB.
2.56 MB. Bytes में बोलो. 1024 से multiply नहीं करना. See, the last block is less than 4 MB, so it is 2681071 bytes. So whatever Ritika you answered is correct. Just multiply that 2.56 MB with 1024, you'll get the same thing. Okay. So now if we are clear that how it is split and how all it is done, you can raise your hands, please, all of you. If you understand the blocks, then I'll go to the next step. We go to user also, but usse pehle we'll, okay, fine. You are getting. Even if you don't understand today properly, there is always a next class. Don't worry. Lower your hands, please, all of you. अभी मैं ये सब डिस्कस नहीं कर रहा हूँ, ठीक है? आई एम अज्यूमिंग कि आपने पिछले सेमेस्टर में ये परमिशन ओनर ग्रुप सब समझे हैं, बट आई विल एक्सप्लेन इट टू यू इन माय नेक्स्ट क्लास. ओके, so you see one thing for directories. Okay, this starts with a D. Amit, the block size and replication does not matter because directories do not take any space, right? In the distributed file system, the size of directory is 0, replication is 0, block size is 0. Directory के लिए हमेशा ऐसा ही रहता है. Okay. Now let's discuss one very important thing. Mridul, lower your hand if you don't have any questions. Yeah. Let's discuss one very important thing. I told you something known as a checksum. So if somebody knows something about this checksum, whatever you have studied in your 4 semesters, you know, or whatever you're going to study in this information security in the 5th semester, if you can just tell me what do you understand by checksum, we can begin a small discussion. Very interesting one. Anyone can start a discussion. Checksum. Do you know what it means? Okay, Varisha is there. Yes, Varisha, go ahead. Varisha, you can unmute yourself.
Sir, it is a method.
Yeah.
Uh,
Yeah.
like I have studied
Yeah,
in
yeah,
C++.
go ahead, please. Yeah. What is it? Checksum is a method, right?
Yes, sir.
Okay. Anyone else? Okay, Varisha, we'll have a discussion. Yes, anyone else who wants to participate? No. Okay, that's good that you don't know about checksum. Checksum is, wherever over some communication lines, you are sending some data. You want to ensure that it is not tampered. Okay, somebody is not, just intruding into it or changing it or modifying it, so that whatever you are trying to send from source to destination goes just like that. The source and the destination, the files are the same, exactly the same. For that, you can generate a checksum for both the files, at the source also, at the destination also. And if the checksum is same, that means file has not been tampered with. So this you can see here in Hadoop. Okay, how? Let's see. First of all, let's go to, I want to take you to your name node directory. Okay, just see how we go there. Click on files, click on computer, go to your user folder, go to your local folder, then to your Hadoop store. फास्ट तो नहीं कर रहा मैं, पाथ ऊपर आ रहा है, देख लेना. Can you see? I have reached here. User, local, Hadoop store, HDFS. We created both these directories here. You remember? We created these directories. So this directory contains the metadata. Let's see it. Name node, current. See the all the files, the edits files, and see the FS image file. Can you see? The MD file, MD5 files are the checksum files. They also keep track that everything is fine. So you see there are so many edits files. Can all of you see? Edits, different. Hai na? This is the current, like when we started our cluster, this is the current edits in progress. 294. Okay. If you open it, then maybe we don't see anything in this. Yeah, we don't know how to open it, so it won't be opened, right? And this is the image, the FS image file, the persistent file. We don't look too much into this because we won't understand anything out of it, but this is how it is. The name node directory stores your edits and FS image, and after your checkpointing they are merged and a new edits, blank edits is created. What is interesting is here in your data node. Now have a look at your data node. First, current, right? Then this is the block pool ID. Important. Your data node, in your data node, there are a large number of blocks on different data nodes. Here in this case, in our system, we are just having one data node. So we have one block pool ID here. Okay. And then when you double click on it, it will show you current and temp. Go to current. See, this folder contains finalized. Very interesting thing I'll show you. Finalized means all the blocks which have been finalized and have been written into the cluster. Okay. And here RBW means, finalized means all the replicas which have been written into the cluster successfully. RBW means replica being written. Okay. It is blank right now. Okay, because all the replicas, all the files which you copied, the replicas have been written. Okay, I'll keep this screen here for you. I'll go here. Important thing that if you delete something from here, okay, if you delete something from here, it will go permanently. Okay, it won't go to something known as a trash. We'll discuss trash maybe at 12. Okay, so I'll just remove it from here. Okay, be very careful. I removed it. It goes. Okay, it says permission denied. Now I think we must configure our trash first. Okay, we'll wait for this. Let's configure our trash. So there is a file for you. Very careful, all of you. Very important thing which all of you need to do on your clusters after you learn it today from me. So let's come back to our discussion, our original discussion, that there is a /user/hd user folder in the cluster. Okay, so but it is not visible here. It's not visible. You see, there is no /user folder here. It is there if you set up your trash configuration. So let's see whether we have set up a trap. It's in the core site.xml file, right? So let's go there. Let's go to our core site file. Keep on noting, please. आपको ये सब करना है. Let me open the core site file. गुम हो गई. This is a core site file. See, there is no trash property here. We have not set it, right? तो set कर लेते हैं. Discuss maybe आज या कल कर लें, ठीक है? ओहो, ये तो कॉपी नहीं होगी यहाँ पर. Just a second. इसमें हमने रखा कि नहीं कुछ? Just give me 1 minute, all of you, right? Oh, there's nothing here. अब इसको लिखना पड़ेगा हमें. लिख लें. Let's write it, okay? We need to write it. इसको कॉपी करते हैं. You need to wait for some time here, okay? I'll be copying it and then editors are a bit different in Linux. They don't work very easily like they do in Windows. So I've copied ज़्यादा ही कॉपी हो गया कुछ. चलता ही है. Just give me some time, please. Actually, from your host operating, you cannot copy files into your or copy text into your guest operating. I'll just remove it and let's hope that it works properly. I'll be setting up two properties, two trash properties. You know, to set up trash, you must set a property. I'll set it here. उसको भी निकाल दें. So the property is fs dot trash. It is trash dot interval and trash dot checkpoint dot interval. I'll set this as 3. Okay. I'll explain it to you what it means. I'll set it as 3. Then I'll copy it here again. The second property name would be fs.trash.checkpoint.interval. Let's check it so that we are on track, and let me set it as 1. Okay. fs.trash.checkpoint.interval. Okay, fine. Let's assuming that we are on track here. There is no problems. Let me just check it so that there are no problems. Yeah, this is again. We may extend our class today. Okay. Just see all the tags are proper. I think they are proper. So let's save it. Yes. So let me now delete a file from Hadoop fs -rm /5csc1. If the trash is correct, this will do. It will show the property also. Seems okay. Let's see. Let's see whether 5csc1 has been, whether the user folder is there or not. That is more important. So let's go there and just refresh it. Can you see the user folder now? So that is what all of you need to do. If you want to activate your user folder, because user folder is there, but it is activated when you configure your trash. Okay. So now you can see a user folder that we have been discussing for the past 30 minutes. If you click on it, let's see what it does. So again, it is saying permission denied. Okay. It is saying permission denied. It is not letting you go there. So let's try another thing here. Let's try this change mode command. So you see how effective these ch mod, ch group जो आपने पिछले सेम में पढ़े थे या पढ़ के छोड़ दिए थे, how effective this is. I've changed the permissions. The permissions were not set for everybody. So for myself, the first number 7, that is for the user owner. So I have made all the permissions, right? So now I hope you've noted this command, very important one. Hadoop fs -change mode -r means recursively whatever directories are below user, all would be opened for user 7. For the rest, it would be 55. Okay. I hope you understand what this 755 is. If not, then in next class we'll discuss. Okay. See now, if you click on user folder, you can go into it. You see in the user folder, there is this HD user folder. This is your trash, which you've just configured. Okay. Let's go to trash. Okay. You see what has happened here is very interesting. In trash, there is a current folder. Okay. In current, there is a 5csc1 folder or a 5csc1 file, sorry, that we just deleted. So it will stay there for 3 minutes. That is the interval it stays in the trash. After that, it will move out of trash. And this folder, you see current folder, it might change after some time. Okay. So right now it is current here. So have you, I'm putting a break here for 2 minutes. Have you understood what we are discussing? To activate the user folder, we must configure trash. How we configure trash? Very simple. Open the core site file, add just 2 properties here. The properties are fs.trash.interval. Meaning is that if you delete a file, it will stay in the trash for 3 minutes. And after 3 minutes, anytime it can be moved out depending upon the garbage collection of the distributed file system. And fs.trash.checkpoint.interval means that after every 1 minute, it will check for all those files which need to be moved out of the trash. It will be checking checkpoint, right? I hope you have understood these 2 properties. Only once you configure this in your this file core site.xml, only then the user folder is active. Now let's go back to all our commands which were not working. They'll work now. So let's go to the basic first command. Do you remember this command? What it should list? You are saying कि मेरा जो default जो path है उसमें जो files है वो करो. So can anyone answer what will result here? Yeah, waiting for your responses now. If I use this command now, what would be displayed on the screen? अगर आप नहीं आंसर कर रहे, that means it is not 100% clear. Obviously, I'm not mentioning any path. If I don't mention any path, it will display the default path, that is user/hd user. तो उसके नीचे कौन सा folder है? .trash. It will display the trash folder. What is the problem in this? Why are you hesitant to answer? It will display the trash folder with the complete path. Can you see now? See this output now, and then again help me with this output. Keep on writing, please. Yeah, this is the same output. This is the same command. Okay, I'm mentioning my name node default folder. If I do like this, this would be root. So I'll just do like this. Can you see? Now the only difference is that at the end here it is just mentioning that in your default path this folder is existent, trash. Whereas here it is giving you the complete absolute path. Okay. So if there are any questions you can ask. फिर आपको वो दिखाने हैं सब मेटा डेटा और वो सब चेकसम वगैरह चलना उसके ऊपर. Yeah, please. No questions. That's good. That's good. That I hope you've understood this. So now you see it looks better. You have an interface which tells you, yeah, there is a user folder. So देखिए अब trash में कुछ change तो नहीं हो गया? अभी तो change नहीं हुआ कुछ है ना? Okay. So ये कब delete होगा? 3 मिनट के बाद होना चाहिए. So लेकिन अभी delete नहीं हुआ है. So इसको हम क्या कर सकते हैं? We can force it, still it's not guaranteed whether it will go or not. There is a expunge command which will empty the trash. The Hadoop expunge command is used to empty the trash. Let's do it. Okay. So now let's go there and let's see if this folder has changed. Yes, it has changed. With the expunge, you are forcing it to go now. So it has created this thing, a timeline. It is the date is 27th August 20, time is 11:48:26. Your file is here now. Okay. So this is how it goes. We'll discuss more about it in our next lecture. Let's now come to the other part. User folder is clear. How to activate it? जिन्होंने install किया हुआ है, they can do it. Okay. Problem आएगी, they can ask. Let's go to our computer now. Very important point I'm going to discuss now for the next 15 minutes. So pay attention. I was talking of this, talking of data node, then current, then your block pool ID, then current. So I was discussing here that there is a finalized folder, there is a RBW folder. Finalized contains all the blocks that have been written, and RBW means the replicas that are yet to be written or which are being written. So replicas being written. They come to this folder. Once they are written, it is empty and all the replicas are here in the finalized folder. Let's go here. Let's delete this. I'm deleting this. Okay. Now it will work. Again, same problem. Okay. Let's try one more thing with this. If this is a problem, one more setting can be done in your configuration. If this problem occurs, actually this won't occur in 2.x, it is occurring in 3.x. Okay, so let me just have this thing. Let's have a break of 2 minutes. Let me just locate this file setting. Okay, Just a second. I'll come back. Yeah, this is the, sorry. Can you see the screen? If you face the problems in version 3.x, then you need to make these two settings, or either one of this will do. I think this second one will do. We need to copy this property into our core site.xml file. If we do this, it will be letting us delete from the web UI also. So it is not allowing from here. Let's try from here. Hadoop fs -rm /had star dot star. Should work. Let's see. Yeah, it has deleted. Okay, it is saying move to trash at whatever. No, it is writing a complete path. So now you see it's not here. So what I'm saying is that if you want to use this delete button here, then you need to make this configuration change. This one. You can do both. I'll send this file to you today. Okay, it contains further details here for the browsers and all. So you just make these property changes in your relevant files. So it will allow you from the web UI also. The now important point. Let's reload it. This file is not there now. Okay, just 15 minutes more, please. Okay, important point of checksum, so that we have a good lecture today. What I'll do is look very carefully here. Can you see this file Hadoop 321 tar? I'll copy this file into my cluster. So remember the block size is 2 MB है ना, पहले 4 था जब मैंने कॉपी किया था, अभी 2 MB है block size. How can we check? We can just open our which file was this? This file. So block size is 2 MB, right? So let's list the size. It is 343 MB. Okay, 343 MB का मतलब है 150 140 170 172 172 ब्लॉक्स बनेंगे, है ना, 2 MB के हिसाब से. So when all these blocks are being written, we will just go to this folder to see whether actually they are being written. I'll open this folder for you. Okay, and I will issue the copy command now. Be very careful to note Hadoop fs -put the file name is had this to root. Okay, मैं इसको copy कर रहा हूँ. Okay, it will show on screen also. It does not show on screen in versions 2.x, but in 3.x it will show you the security part also. Okay, and we will go here and see that the replicas being written would come here also. Okay, and they will disappear also. Okay, so let me just press enter here. Let it start here. Yeah, it has started here. So let's go here. Can you see? See, the blocks are being written. Important thing है, दो चीजें लिख रहा है. One, it is the block ID. One is the block meta. That is your checksum that we'll discuss. See, replica being written. Okay, and then it is being transferred to the finalized block. Interesting, I suppose. All the replicas first come to the RBW folder and then they go to the finalize. So they are finished, done. Okay. So your RBW is free and your finalized will have, see the structure of finalize, subdirectory 0, subdirectory 1. It contains some blocks. That means subdirectory 0 contains, so replicas are still on process, I think. पूरे नहीं आए हैं इसमें अभी. So let's wait. It will take some time for them to come, or maybe some more subdirectories may be created. Take some time. Yeah, now they have come. Okay, can you see all the blocks, the 120 odd blocks that I was telling you? So if this part is clear, so you can raise your hands. If this is clear, if whatever you've seen is clear, you can raise your hands, all of you. Any doubts would be entertained in the next class, but I don't think there are any doubts. You're seeing whatever is happening, you are seeing it on screen, right? So what we do next is, let's talk about checksum now. The last discussion for today. Lower your hands, please. Thank you. About checksum. So let's go to cluster. Now I'm going to discuss very important thing with you for today, finally for today's class. Can you see this file? A 30 byte file. Can you see it here? Okay. The file that we created today, 5CSE2. What is its block size? Kindly have a look. 30. Block size is 30. Okay. So when it is stored there in this directory, here, what is the block ID? फिर देखना पड़ेगा. 914 एंड में, ठीक है, इस ब्लॉक आईडी का 914 एंड में. सो लेट अस लोकेटेड हेयर. इसमें नहीं है तो इसमें देखें 914 ढूंढना पड़ेगा, है ना, बहुत सारे ब्लॉक्स हो गए. सो let's make things simple for you again. Let's again remove that big file from there. Hadoop fs -rm had. I'm removing the file that I just copied. Okay, I'm removing it from there. So it's no longer here now. If we just see, the file is not there. Okay, the file has been moved to trash. Now if we go to our these folders, you see, we abhi thode जरा, अच्छा अभी it is in there now. We have not emptied the trash, so maybe, okay, let's locate that 914 folder. Okay, let's take some time. It's in order, I think. This is the folder 914. See the properties. Is it the same 30 bytes, that block? If you agree, raise your hands, please. Important मेरे को इस discussion में आप सब साथ में चाहिए. I'm telling you, the block which you see there on your web UI, which is there in this data node folder, it will have two things. One, a block, that is a 30 bytes block, okay, block ID, and one would be a metadata checksum file, which will check that the file is okay. That is this meta. Can you see? See this block 914, its meta file is here, _1090.meta. What is the size of this meta file? We can predict, we can know. That is how the architecture is. Okay, so remember, as per the settings of architecture, for every 512 bytes, okay, 4 bytes are added to the size of the meta file. One thing. And the minimum file of the meta file is 7. I repeat, minimum file is size is 7, and for every up to 512 bytes, 4 bytes would be added. So can you respond by raising your hands? What is the size of this file, meta file, that you see on your screen here? What is its size? I repeat, if somebody wants to answer, first lower your hands, all of you, and then raise your hands. I repeat, for a file of size up to 512, 4 bytes would be added to the meta file, and minimum 7 bytes are already there in every meta file. Okay, if the size is more than 512 and less than 1024, then 8 bytes would be added. That is 4 bytes multiples are added. So can somebody tell me what is the size of this meta file? Ritika, good. It's easy, I think, if you have understood. Yes, Ritika.
11 bytes.
How much?
11 bytes.
11 bytes. That's good. Let's first check it and then see whether you've understood or not. See, 11 bytes. कैसे बनता है ये मेटाडेटा? जब भी कोई ब्लॉक आईडी है, उसका जो चेकसम वाली फाइल बननी है, मेटा फाइल जिसको बोलते हैं, तो 7 बाइट्स मिनिमम साइज होना ही होना है, प्लस जितना उसका साइज है उसके अकॉर्डिंग और बाइट्स ऐड होंगी. सो इफ इट इज अप टू 512 बाइट्स, देन 4 बाइट्स आर एडेड. 512 to 1024 bytes, another 4 bytes are added, and so on. ठीक है, समझ में आया? चलो फिर let's ask you one question, final question for today, and then maybe some questions from your side. ध्यान से देखना, एक छोटा सा एक टेस्ट ही है आपके लिए. See the size of this file, all of you. It is 8980. Can you see? इस फाइल का साइज चेक कर लो, 8980 है. इसको मैं क्लस्टर में डालूंगा तो इसके कितने ब्लॉक्स बनेंगे आपको पता ही है ना? कितने बनेंगे? Shaman wants to answer. Okay, Ritika wants to answer. Yes, Ritika.
So one block.
It is 8980. आपने
It
अभी
is
तो
in bytes.
हाँ 8980 बाइट्स है, तो कितने मेगाबाइट हुए? Easier now? Oh, sorry. कितने किलोबाइट्स हुए? 8.8. Okay, we are talking in M. Sorry, it is 1 M. Perfect. Yeah, I thought it is 8980. No, it is 8980 bytes. True. So it is one this thing there. Let's first copy it there, and let's copy it in root. So it will come here. It's not here right now. Once we refresh it, it will come. So if we see, it's only one block. The block ID is 2087 end में आ रहा है, याद रखो, ठीक है? Last question for today. What is the meta size for this file, this block? You know, this block ID, this will have a meta file also as a checksum. So what is its size? Use your calculators, I don't mind. Then we can go to our folder to see. It's 2087 at the end. Let's see where it is. इसमें नहीं है. Let's go here. This is the one, the latest one. Can you see? This is our file. See, इसमें नाम नहीं है कोई फाइल का. Examples.desktop. There is no name. Okay. It's only the block underscore this ID 2087. Okay. My question is, what is the size of this file? 79 bytes. It shows. कैसे बना? 8980 को डिवाइड करो 512 से. You should know how it is done. Yes or no? If you divide 8980 by 512, it is 17.53. So 17